Now we are on third point of laws concerned to the operations on sets. Number third point, laws of complement. For any set A, there are point A union A complementary is equal to universal set. Suppose the members of universal set are into bracket 1, 2, 3, 4, 5 bracket over, and members of set A are into bracket 1, 3, 5 bracket over. Then universal set difference A set is equal to, first we place the members of universal set 1, 2, 3, 4, 5 bracket over, and sign of difference. Then we place the members of set A into bracket 1, 3, 5 bracket over. We see that 1, 3, 5 are similar to both sides, so these are cancelled, and now we write its complement as A complementary is equal to into bracket 2 and 4. These are remain in the universal set, so these are as complement. Now we write A union A complementary is equal to into bracket, first we write the members of set A 1, 3, 5 bracket over, then sign of union, and then members of A complementary into bracket 2, 4 bracket over. We find that 1, 3, 5, 2 and 4 are now the members of new set A union A complementary. We write it in sequence. So A union A complementary is equal to into bracket 1, 2, 3, 4, 5 bracket over. These are the similar as the members of universal set, so we write as A union A complementary is equal to universal set. Now we are on point B. A intersection A complementary is equal to null set. Suppose universal set has members A, B, C, D, E bracket over, and members of set A are A, C, D bracket over. Then universal set difference A is equal to into bracket, first we write the members of universal set A, B, C, D, E bracket over, and sign of difference. Then we place the members of set A, C, D bracket over. Now we see that A, C, D are common to both sides, so these are cancelled, and we write remained elements as A complementary is equal to B, E bracket over. Now we write as A intersection A complementary is equal to, first we write the members of A set, so into bracket A, C, D bracket over, and then sign of intersection. Then the members of A complementary B, E bracket over. Now we find there is no any member common both sides, so set is empty. So conclusion is that A intersection A complementary is equal to empty set or null set. Now we are on point number C. Into bracket A complementary whole complementary is equal to set A. Suppose the members of universal set are 1, 2, 3, 4, and members of set A are 3, 4. Then universal set difference A set is equal to, first we write the members of universal set 1, 2, 3, 4 bracket over, and sign of difference. Then we write the members of set A 3, 4, and then we see that 3 and 4 are common to both sides, so these are cancelled, and remaining members are as A complementary is equal to into bracket 1, 2 bracket over. Now we write as universal set minus A complementary is equal to into bracket, we place the members of universal sets first 1, 2, 3, 4 bracket over, and sign of difference. Then members of A complementary 1 comma 2 bracket over. We find that 1 and 2 are common to both sides, so these are cancelled, and remaining members 3 and 4 we write as into bracket a complementary whole complementary is equal to into bracket 3 comma 4, and 3 comma 4 are similar to the members of set A, so we write its conclusion into bracket a complementary whole complementary is equal to set A. And now on point D, there is universal complementary is equal to null set, and null set complementary equal to universal set. So suppose the members of universal set are A comma E comma I comma O comma U bracket over, then first we write as universal set minus or difference universal set is equal to, we write the members of universal set A, E, I, O, U bracket over and sign of difference, then we again write the members of universal set A, E, I, O, U. We find that all these members are common to both sides, so these are all cancelled and the set is now empty. So we write as universal set complementary is equal to empty set, or universal set complementary is equal to null set. Similarly, universal set difference null set is equal to, first we write the elements of universal set A, E, I, O, U bracket over, then sign of difference and then empty set. So then we find there is no any member common to both sides, so we write all the members of universal set as null set complementary is equal to into bracket A comma E comma I comma O comma U bracket over. So we see that these all members are the similar as the members of universal set. So in conclusion, null set complementary is equal to universal set. That's all.